Okay, so it's finished creating our account credential. So the next order of business is let's get our EKS cluster created. I'm only going to create one just so that we can see what the process looks like. And then we'll do all three in the next video through the automation script. So we'll create a new EKS cluster. I'm going to call this tap view. And we're going to add it to our TMC operations group and click next. Then we want to make sure our account credential is the right one. All this other stuff, the Kubernetes version, that's fine. And this role is one of the roles that were created from our CloudFormation template, executed in one of the previous steps. We do have to change our AWS region to US East 1. And then change the network to Tanzu VP stack, which we created in the prior video. So this looks perfect, right? We've got our 4 subnets, 2 public, 2 private. In the advanced settings section, I did not explicitly create a security group, so it's optional. We'll leave the default. And for the endpoint access, since we've got public and private subnets, we want to make sure that this is selected and that all traffic is accepted into the VPC. Okay, we'll click next. Now, this is a 2-step process, right? It's just like creating an EKS cluster in AWS. You have to first create the control plane node, and then you add node groups, or in this case, node pools. So we'll name this tap view node pool. And it doesn't really matter. We're deleting this cluster. So this is another one of the roles. So in order to create worker nodes in our node pool, TMC is going to assume this worker role. Okay, that was also created as part of the CloudFormation template. Everything else we can leave as the default in here, the instance type, and we can hit next. So if you're at all familiar with creating EKS clusters, you know that that can be a lengthy process. And so TMC is going to take about 15 to 20 minutes for the EKS cluster, and then another 5 minutes or so to install its various agents and so forth. So once that is complete, we will resume from there. All right, we're back and everything looks perfect. Now, I know you're asking yourself, but what about that big glaring red error message on the top? Well, I find this to be an erroneous error because everything else is in good working order. If we go over here to the Node Pools tab, we'll see our 2 nodes in a healthy, ready condition. On the Nodes tab, we can see them individually and the EC2 instances. And even all of the extensions and so forth have been installed properly. Now, I've also seen that this error message does tend to take a little bit longer to disappear. So I want to take a moment here to just talk about these extensions and these agents that Tanzu Mission Control installs to our cluster. And this is to enable bidirectional communication so that our cluster can report back to TMC various health statistics and metrics, okay, that we see here on the page. Now, insofar as Tanzu Mission Control talking to our cluster, that would be for the purpose of sending updates, different configurations, integrations, and also of note, these policy agents that we see. Now, if we define a policy at either the cluster level or at the group level, these agents can be told on the cluster to be applied. So let's look at these policies here for just a moment and talk about them briefly. So if we had a use case to define various access restrictions and across our clusters, we can define a security policy to define who, what teams and so forth have access to which clusters and cluster groups. We can set up an image registry policy that tells TMC that only allow container images to be pulled from, for example, Google Container Registry, right? Or let's say we're in an air-gapped environment and we only allow images to be pulled from a private harbor instance. We can set up a network policy to define various ingress and egress rules. So for example, let's say we have a pod that's hosting a database, and we only want middle tier components to be able to communicate with this database pod. We don't want any other pod or any other component communicating with our database. Okay, only this middle tier component. We can set up a network policy rule to only allow that to happen. We can set up quota policy. So for example, here, developers, we can restrict them from spinning up resources that go way beyond threshold, right? So we can define like memory limits and CPU limits so that we don't exceed budgets and so on and so forth, just for development purpose and testing purposes. And then we have other policies here, custom and mutation. So I think that will do it for that. So if we come back over here to the clusters tab, everything is in a healthy state. And I just want to come over here to our EKS page in AWS. Okay, so there is our tab view EKS cluster. And if we just drill down here, we'll also see the node pool with 2 nodes attached to it. All right, so we have achieved our objective of going through the Tanzu Mission Control portal and going through some of the major features here and the value proposition and so on. In the next video, we will then go ahead and do all of this again, but with an automation script. Okay, so we'll look forward to seeing you then. Thanks for watching.